Hi guys, this is Group 18 and today we present to you about the three open source softwares and the security issues on them on which we have researched upon. The first software is accounting, which is an online accounting software that has tools that you need to manage your money from invoicing to expense tracking to accounting. Some of the features are multi-company, which lets you to manage finances of multiple companies from one admin panel and also assign users to different companies. Record everything. This feature allows you to automatically create invoices, revenues, bills, and payments for ongoing jobs with just a click. Powerful reporting, which produces detailed financial reports to help you better visualize all the information you need to improve your business. Accounting is hosted on GitHub and is open for everyone to contribute. Accounting is built with modern technologies such as Laravel, Bootstrap, RESTful API, etc. Laravel is one of the more well-known existing PHP framework with thousands of contributors and modern tools such as ORM, painless routing, powerful queue library, etc. Now let's talk about the vulnerability that has affected the software. The vulnerability here is the weak password recovery mechanism for the forgotten password. The affected versions are 2.1.12 and older. So what is the vulnerability? So it is the change of host of a signed URL using the X forwarded host header. This allows the attacker to generate a malicious password reset email. The legit user receives the link in which the attacker domain was appended with the password reset token. So now if the legit user happens to click on the link of the password reset token, the attacker will get the password reset token as the request is sent to a server which the attacker controls, and using it the attacker can change the legit user's password. So this is a type of the host injection. So now let's see what is the host injection. This attack allows the attacker to generate a malicious password reset email with a link to a website controlled by the attacker. Host injection attacks can happen via the X forwarded host header or the host header. The X forwarded host header exposes the application to the host injection attacks if it is behind the load balancer or the reverse proxy that does not set trusted host. So if the application has already set X forwarded host header or at the reverse proxy level, you may ignore the vulnerability. The second one is if the web server configuration is insecure, it may allow the host injection attacks via the host header. This may happen if you use the server name wildcards or do not have cache all server configurations to cache all the requests with unrecognized host header. Let's see the options to fix the vulnerability. The first one is to use the trust host middleware and simply adding it to the middleware in the Laravel. The second one is that using the trust proxy headers. So by default, the trust proxies middleware whitelist all the headers including the X forwarded host. You may specially set the whitelist headers to only X forwarded in the application so that even the attacker sets the X forwarded host header, it will not be trusted by the application itself. The third one is to explicitly set all the X forwarded host headers to the reverse proxy. So these are some of the fixes for the code. Now let's see how the code was fixed by the developers. In the code, we see that the middleware, the trust host option was commented by default in the Laravel. All the developers had to do was remove the comment, and this is the same fix as the first option in the last slide. So it is so fascinating that just one line of code being commented could cause such high impact. That's it from my side. I'll forward it to Naimesh for another software.
Thank you. I am Nemish. I'll speak about the second bug in the list, which is Terraform by HashiCorp. So, starting off with HashiCorp, which is a parent company, is a software company with a freemium business model based in San Francisco. So, HashiCorp provides open source tools and commercial products that enable developers, operators, and security professionals to basically secure, run, and connect to cloud computing infrastructures. HashiCorp has made a lot of useful tools in that matter, and not to mention that we used one of his open source product a few weeks back in one of the assignments in this course, which is Vagrant, if you remember, which is an open source software product for building and maintaining in virtual environment. So Vagrant, Packer, Nomad, etc. are some of the best by HashiCorp. Now, what is Terraform? Terraform is an open source infrastructure as a core software tool created by HashiCorp. So user defined and provide data center infrastructures. Basically what Terraform does is manages external resources such as public and private cloud infrastructures, network appliances, and software as a service, as well as platform as a service with the providers. So Terraform does the lifecycle management of AWS, which is Amazon Web Services, The bug is related to AWS over here in Terraform, which we are going to discuss. So AWS resources like EC2, Lambda, and many more like DynamoDB, etc. are managed over here. This provider has maintained internally by HashiCorp AWS provider team. So it manages the AWS IAM user login profiles, which are with limited support of password creation, as well as when you click on the forget password in the new password generation, it uses a public key encryption technique to encrypt those passwords and safely transport to the user. So to reset an IAM user login is done via Terraform. Coming on to the vulnerability, is limited entropy using the PRNG. So what is PRNG? Is a pseudo random number generator. Like if a pseudo random number generator is using a limited entropy source which runs out if the generator fails, in case the program may pause or crash. So insufficient entropy refers to the initial internal state or seed, we can say, of a PRNG being so limited that it or the PRNG's actual output is restricted to more easily brute forceable range of possible issues. So basically what the external hackers can do is brute force the attack, and they can guess what exactly the password is or how many characters are in there. So if the PRNG is so limited the entropy source, then the potentially weak passwords of the random numbers are weakened in encryption and they can be bypassed by the hackers. So moving further, the what are the exact issues over here is that they used the generate password function, which had a very limited entropy as they used a math rand function in the Go language. So what math rand function does is implements a large selection of pseudo random number generators, but they are not secure. Like they are at a level at easily guessable passwords. The main issue is it will explain in simple words that the password generation method samples one character from each character set, then shuffles the results. This results in sub-optional password entropy. As for a 20 character long, for example, one would know it contains exactly 5 lowercase letters, 5 uppercase, 5 digits, or 5 special characters. So what are the main changes they made in the code to get rid of this issue was they used first thing, the simple math random function was cancelled, and they used a crypto random. So what crypto random done is cryptographically secure pseudo random number generator. So it has a limited interface. So that solved the half of the issue, and they used the generate password function. They had a character set of the smaller lowercase letters, uppercase letters, numbers, and the signs, but those signs are not supported by the AWS. So that's why they changed it to a different character set and modified that. Further, the last screenshot states they use the result over the range. So here they had to get down all the lines of code in the red, which says that they used the math random function and they used it with that. So there is a result which makes the things better over here. Moving on further, the third issue will be explained by Cyril. Thank you.
Thanks, Ramesh. The third one is Sopizer. So, what is Sopizer? Sopizer is an e-commerce company who creates online stores, marketplaces, product listing, B2B applications, transactional portals, and much more using Sopizer's secure, fast, and reliable open source e-commerce software. So now let's go to the vulnerabilities. In Sopizer older versions, who are older than 2.11.0, they are API or control-based versions. In that, negative quantity is not properly validated, so that creates incorrect shopping carts and order total. This vulnerability makes it possible to create negative total in the shopping carts. So here the main vulnerability is input validation. Let's explore the input validation. Input validation is a frequently used techniques for checking potentially dangerous inputs in order to ensure that the inputs are safe for processing within the code, or when communicating with others components, when the software does not validate input properly, an attacker is able to craft the input in the form that is not expected by the rest of the application. This will lead to parts of the system receiving unintended input, which may result in altered control flow, arbitrary control of the resource, or arbitrary code execution. So this vulnerability has a higher impact in the integrity. So let's see the detection methods for the input validation. So here there are three main detection methods: automated static analysis, manual static analysis, and fuzzy. So in automated static analysis, some instances of improper input validation can be detected using automated static analysis. A static analysis tool might allow the user to specify which application specific methods or functions perform input validation. The tool might also have built-in knowledge of validation framework such as struts. The tool may then suppress or deprioritize any associated warnings. This allows the analyst to focus on areas of the software in which input validation does not appear to be present. Except automated static analysis might not be able to recognize when proper input validation is being formed, leading to false positive. Example like warnings that do not have any security consequences or require any code changes. The next one is manual static analysis. When custom input validation is required, such as when forcing business rules, manual analysis is necessary to ensure that the validation is properly implemented. The third one is fuzzing. Fuzzing techniques can be used for detecting input validation errors when unexpected inputs are provided to the software. The software should not crash or otherwise become unstable, and it should generate application control error messages. If exception or interpreter generated error messages occur, this indicates that the input was not deleted and handled with the application logic itself. So let's check the code changes. So first one, here they are adding a condition that the quantity is less than 1 so that there is no negative total. In the product availability function, the developer has changed the condition so getting the availability quantity as 0 and less than 0, that nobody will able to add an item that is not in the stock, and it will throw an exception as the product is not available. The next screenshot. Here they did the same thing as per the previous error, and then they overrode the implementation of the code changes. The next one. Here they change the condition to check whether the customer has existing shopping cart or not. So these are the code changes they've done in the Shopify.
Thank you, Saral, for your input. These are the references that we have used in the project and are in the IEEE format. Let us know if you have any questions. Thank you.